Okay, welcome back. We're going to look at 6.5, solve problems using quadratic equations. Make sure you pay close attention to this lesson. This is probably one of the more difficult ones because we are solving word problems, which is not everyone's favorite. So when solving a word problem involving quadratic relations, it's important that we, number one, write the relation in the form that's most helpful for the given situation. So there's a few situations that word problems tend to ask us. Either they're asking us to solve for x, they're asking us for the max or min, they're asking us for when something hit the ground, so they want the x-intercepts, or they're asking us for the initial value of something. So if you see the word max or min in your word problem, that is asking you for the vertex. So max and min is the vertex of the parabola, which means we want vertex form. Once you have vertex form, you can pick out that vertex very easily. It's just HK. So if we have vertex form, that will help us in those situations. If they're asking us to solve for x or find the x-intercepts, that's when we would want standard or factored form. Standard form or factored form. Can you solve for x given vertex form? Absolutely. We can isolate x. We can get x all by itself in vertex form. Usually they give it to us in standard form or factored form anyways, so we would just want to keep it in that form. So let's look at an example here. The equation represents the profit in dollars. So someone is selling something, and P is the profit, and N is the number of tickets. So they're selling tickets. What is the maximum profit, and how many tickets did they have to sell? Keyword, max. Max profit. So they want to know the vertex of this parabola, which means I want the vertex form. So who remembers how to go from standard form to vertex form? We are going to complete the square. That's 6.1. 6.1 was completing the square. So I'm just going to rewrite the equation here. P equals negative n squared plus 580n minus 4800. Completing the square is all about creating a perfect square within the equation and then factoring that perfect square. That'll get us vertex form. So in order to do that, we need to make sure that our a value is 1. I can't find that perfect square, the magic number, unless my a value is 1. So we always need to common factor first if our a value is not positive 1, which means in this case I'm just taking that negative out of the first two terms. Okay, so I took the negative out of the first two terms. Now I'm going to create a perfect square. So equals n squared minus 580n. I need to figure out what this third term is going to be to make this a perfect square. So we're going to find our magic number. Our c value is going to be the b value divided by 2 squared. So b divided by 2 squared. In this case, it's going to be 84,100. Yes, that is a big number, but it's okay. So we got plus 84,100. And because we added it, now we have to subtract it. Outside the bracket on the end is this minus 4,800. Don't forget about it. We're going to keep that all the way down. Okay, so why did I find that magic number? I did it so that I could factor this perfect square here. Keep your negative out front. Square root of the first term, first sign that you see. Square root of the third term, square root of 84,100 is actually 290 squared. I still have my subtract 84,100. However, that is in brackets with that negative sign. Subtract 4,800. I want to remove these square brackets, so I want to distribute that negative to both terms inside. If you have a negative out in front of the first one, it's just a subtraction sign and then n minus 290 squared. Negative 1 outside times negative 84,100 just ends up being positive 84,100. And don't forget to subtract your 4,800 on the end. Your very last step, we're just going to combine the two last terms. And if we punch that in our calculator, we get 79,300. 79,300. Make sure we answer the question. Now that I have vertex form, I can see that my vertex is HK 290, 79,300. There's your vertex. So therefore, the max profit, okay, the maximum value that this is going to reach is 79,300. And when does that happen? So that occurs when 290 tickets are sold. Okay, so I changed it to the form that I wanted to get the information that I needed, and I included a therefore statement answering the question. Example number 2. A model rocket is shot straight into the air from the roof of a garage. So it's not being shot from the ground, it's being shot from the roof of a garage. The height in meters and after t seconds can be estimated by the following equation. What's the height of the garage? The height of the garage is where this parabola starts. So we got a rocket being shot up. It's starting here, but how high is that? That is your y-intercept. So this is looking for the y-intercept. How do you find the y-intercept given an equation? You want standard form. And it's given to us pretty closely in standard form. They've just rearranged it, so let's change it back. We're going to put our t squared term first, then our t term, then our constant at the end. Looks like standard form. The y-intercept is the c value. So y-intercept equals 15. And then just make sure you answer the question. So therefore the height of the garage is 15 meters. How long does it take the rocket to pass by a window 10 meters above the ground? So the question is actually asking you, this is the height. So what is t? When h is 10? How long does it take? What is the time to pass by a window 10 meters above the ground? So when the height is 10, how long has it been? So let's put our height in. I should probably change this to h for height. Let's put our height in of 10. And then I'm going to use my rearranged formula because that looks like standard form. And they want us to solve for t. So anytime we're solving, we can actually do this from any form. I'm going to take that 10 and move it over to the other side so that I have a 0 here. If we have plus 15, subtract 10. I'm going to simplify that. Okay. Now we can either try factoring this or we could use quadratic formula. Okay, factoring would be the easiest way, but they're not always factorable. So let's just double check. It's definitely a complex trinomial because we got an a value out front. So we're going to take AC, which is negative 25, and B, which is 22. So are there any possible numbers that would multiply to give you negative 25 and add to give you 22? No, unfortunately. Okay, so if it was factorable, it'd be relatively easy. We could factor it and find the x-intercepts. We'd have our answer. Unfortunately, we can't factor it, so that means we're going to have to use quadratic formula. Must use quad formula. Okay, so you guys just wanted to hear me sing again. quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Our a value is negative 5, our b value is 22, our c value is 5. Let's start subbing in. Minus 4 times negative 5 times 5 all over 2a. I'm going to punch everything under that square root sign in my calculator at once, so I get 584. And then you're going to end up with two answers here. One of the answers is going to be if you add the square root of 584. Our other answer is going to be if we subtract the square root of 584. So if I add them, I'm going to get an answer of 4.62. If I subtract, I'm going to get an answer of negative 0.22. So that's just a matter of plugging that into your calculator, once using the plus, one using the minus. So we get two answers. Which one actually makes sense? How long is it going to take the rocket to pass? Is it going to take negative 0.22 seconds? Absolutely not. That does not make sense at all to have a negative. So therefore our answer is 4.62. It will take approximately about 4.62 seconds. And when does the rocket hit the ground? So when is my height going to be 0? When does h equal 0? So if I put a 0 in for h, okay, I could try to factor it. However, I believe this is not factorable as well. So we're going to have to use quadratic formula. Here's my a, my b, and my c. I need a little bit more room here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to sub my values in. I'm going to plug the stuff under the square root into my calculator to get 784 this time. And then I'm going to have two solutions here. One of my solutions is going to be when I add the square root of 784. My other solution is going to be when I subtract the square root of 784. So if I add them, I'm going to get x equals 5. And if I subtract them, you end up with negative 0.6. So again, just think which one actually makes sense. Is it going to take negative 0.6 seconds for the rocket to hit the ground? No. If we graphed it out, that would be one of the x-intercepts. But when you look at the word problem and you read the question, that one just doesn't make sense. So therefore, it will hit the ground at 5 seconds. Example number 3. A pen is to be built as shown below. Jack can only afford to purchase 30 meters of fencing. To achieve the maximum area, what dimensions should Jack use? This is a great question that actually pops up in grade 11 too. So when you get to this question in grade 11, I want you to flip back to your grade 10 notes and read how to do it. Question states we're finding a max area. That tells me I need my vertex. Okay, so I need to get to vertex form. Now they're giving us all kinds of information here. I got 1, 2, 3, 4, 5 widths, and there's no fencing needed on this side. I just need one of the lengths. I know that these are all going to add up to 30. So I have 1, 2, 3, 4, 5 W's plus my length is going to be 30. So to find the length, I'm going to take my 30, which is my perimeter of fencing. I'm going to subtract the 5 widths. Whatever I have left over, that'll be how long this pen is. Because I'm finding the maximum area, we are going to use the area formula. And the area of this is just a rectangle. It's just the length times width. So my area is going to be length times width, which is 30 minus 5W. And the width is just W. So that's going to find the area of the whole thing. When you multiply, just like if the W is out front, in fact, you can move it out front if you want, but you need to make sure you multiply it by both terms inside. So we have to distribute that. So it's going to be 30W subtract 5W squared, or changing this to standard form, we have negative 5W squared plus 30W. So we have standard form. I want to change it to vertex form. How do you go from standard to vertex? We're going to complete this square. Complete the square. All right, so let's start off up here. We got negative 5W squared plus 30W. When we're completing the square and you have an a value out front, we need to common factor that a value out of the first two terms. So we're taking that negative 5 out. We're going to divide 30 by negative 5 to give us negative 6. And I need this third term to make my perfect square, because that's how I'm going to complete the square. So how do we find that third term? Well, we take the b term, we divide it by 2 and square it. Negative 6 divided by 2 is negative 3. Square that, you get positive 9. So I'm going to add 9, but then I have to subtract 9. For my next step, I'm actually going to factor this perfect square, first three terms. You're going to take the square root of the first one, the first sign that you see, the square root of the last one. We still have that negative 9 inside the bracket, so we have to make sure we multiply it by negative 5. So our next step here is to distribute the negative 5 to both terms. I did some erasing there. Both terms inside. So I got a negative 5 out front. The negative 5 is multiplied by the negative 9 to get positive 45. So therefore, our max area occurs when W equals 3, because that's our H value. And I just want to reread the problem. What dimensions should Jack use? So I know my width is going to be 3. What is my length going to be? So my length formula from here is 30 minus 5W. So 30 minus 15 is going to be 15. So therefore the max occurs when the width is 3 and the length is 15. And this is meters. Okay, so that's a tricky question. Again, that pops up in grade 11. So you are learning it a year ahead. Gabby sells, she doesn't spell them, she sells special teddy bears at various summer festivals. Her profits listed here. This is another one of those profit questions. N is the number of teddy bears she sells during the week. So we're no longer selling tickets, we are selling teddy bears. There's questions that sell bracelets. There's a lot of these profit type questions. So according to this model, could Gabby ever earn a profit of $2,000? So could P ever equal 2,000? In other words, if P is 2,000, is there any possible value of N that satisfies this equation? Well, let's see. Well, let's make a 0 here, and we're going to move our 2,000 over to the other side. Simplify that. in the negatives 2,200. We're going in the negatives 2,000 more, so we're ending up at negative 4,200. And do you remember, if we just want to see if it's possible, we don't actually have to solve for n. We just want to see if there is some value of n that would satisfy this. You can just use a discriminant. To see if it's possible. So for the discriminant, we need our a, b, and c value. It's b squared minus 4ac, so that's what's under the square root in the quadratic formula. We're just going to plug these numbers in here. And you can sub that into your calculator all in one step. Actually, we don't need the square root sign there, do we? Ooh. Let me rewrite that. I was thinking of when it's in the quadratic formula. Okay, so let's sub that in. And plugging that in our calculator, we get negative 1,335. So if the discriminant is less than 0, are there any solutions? No. So since c is less than 0, Gabby cannot make a profit of 2,000 in 1 week. Not possible. There is no value of n that's going to make that possible. How many teddy bears would she have to sell to break even? What does break even mean? Okay, break even means you don't have a profit. You didn't make any money, but you didn't lose any money. So how many would she have to sell in order for the profit to equal 0? That's break even. So let's set p equal to 0. I want to find n. You could try to see if that's factorable, but that decimal number in there is not very nice, so I'm going to guess it's not factorable, which means we're going to use quadratic formula. My a value is out front, my b value is next, and my c value is negative 2,200. So quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Mark for getting the formula correct. Subbing in our values, we're going to have at negative 45 plus or minus 45 squared. I really don't like how I put the bracket around there, so I'm going to change it. There we go. Minus 4ac all over 2a. Didn't leave you guys a lot of room, did I, here? So we got negative 45 plus or minus. I'm going to plug all this stuff under the square root into my calculator to get 265 over negative 0.4. There's going to be two solutions here. One of the solutions is going to be when there's a plus. One of them is going to be when there's a minus. So either, I'll write this out here, either it's a plus or it's a minus. So one way we're going to get 71.8. The other way we're going to get 153.2. So neither of these are actually negative numbers, so they're both correct. She could either sell 71 teddy bears to break even, or 72 teddy bears, or 153 teddy bears to break even. So both of those will work. If she sells either of those, she's going to break even, which means her profit's going to happen when it's in between there. So therefore, you would have to make or sell. Either 72 or 153 bears to break even. Okay, homework, page 311. Obviously, this is going to be the trickiest. Word problems always are. There's so many numbers and words being thrown at you. Just take your time and really think about what the question is asking you. Are they asking you to solve something? Are they asking for the max or the min? Are they asking for when something hits the ground or from the height that it starts at? And then figure out what form of the equation you need and how you're going to get there. Okay, so if you have any questions, we will take this up the next meeting that we have. I'm going to expect that there's going to be some questions, so make sure you have those ready for me.